Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to another series of online lessons. If you haven't already, please subscribe to the channel and leave a like for this lesson. Now, we continue with normal distribution, and basically, last time we were looking at the normal distribution of Z scores. So, these values that have Z that we directly find on the Z score table, this is the Z scores. Now, in today's lesson, we look at random variables that are normally distributed. Okay, we're looking at random variables that are normally distributed, and basically, the the thing that we'll be doing in this lesson is converting these random variables to z-score variables so that we can find their probabilities on the z-score table. Okay, yeah, so that is basically what we'll be doing. Then for a z-score that is normally distributed, so z-score normally distributed, it has a mean and a standard deviation. Okay, and for this z-score that is normally distributed, the mean is 0 and the standard deviation is 1, as you will see written here. So if z is normally distributed, then the mean is 0 and the standard deviation is 1. So when it comes to random variables that are normally distributed, the first value here represents the mean and the second value here represents the standard deviation. So sometimes they won't give you right out the mean and the standard deviation, but you can get them from this formula. Then here you see that you'll be given in the question, so the masses of packaged particular shanshan with mean of that, so that is the mean, and the standard deviation of that. So you'll be told like this, but sometimes you'll not be told, it will just be like this. Okay, so same applies with these values here. So now, how do you convert a normal distribution variable into a z-score? So there is a formula that we use. So that formula is, let me just write it here. So the formula is the probability of z less than x minus mean over the standard deviation. So this is the formula that you're going to use. So for probability of x less than, maybe I'll put small letter x. So in normal distribution, this is equal to that. So that is the formula that we'll be following. So for this variable, so we have x, which is the value after the greater than or less than sign. Then we have the mean like that over the standard deviation. So same applies where x, probability of x, let me say small letter x1, then we have capital X less than x2. Okay, so maybe you're given, you're asked to find the probability of x being between x1 and x2. So how you change this, you say this is equals to the same formula that will be x1 minus the mean. So it will have the same mean over the standard deviation, that looks like an 8. So that is over the standard deviation. We follow the sign that is here. So this is less than, so we put a less than here. So this becomes z less than, then here we have x2 minus, again, that is mean all over the standard deviation. So that is how you'll be converting. So this is the formula. You should write this down. So for probability of x less than small letter x, this is equals to z. We follow the sign. If the sign is less than, the sign here will be less than. If the sign is greater than, the sign here will be greater than. So less than x. So this z less than, we say x minus. So minus, this is the mean over the standard deviation. Okay, if we're looking at x that is between x1 and x2, this will be x1 minus mean over standard deviation. So the sign that is there comes here, less than z, less than, as the sign here, x2 minus mean over standard deviation. So this is how you convert. So let's just look at an example and we move on from there. Okay, so let me see. I think I can write it here. So for this question, I'll work out this question, then you work out the rest. Okay, so we have a probability of x less than or greater than 60.3. So we want this to be a z-score. So this will change to z. Then we change this, we follow the sign as it is, so that is greater than. So we know that the formula is x minus mean over standard deviation. Okay, so now this will be probability of z greater than, our x is the value that is here, okay, which is 60.3 minus the mean will be gotten from here. Remember we said for a normal distribution, the first variable represents the mean and the second variable represents the standard deviation. So the mean is 50 all over the standard deviation, which is 20. Okay, so simplifying that, we have probability of z greater than, so you're going to get probability of z greater than 0.51. So then you know how to work out this probability. So simply, since it's greater than, we say 1 minus probability of z less than 0.515. So we'll look for 0.515 on the table, and that will be the probability of here. Okay, so that is this is equals to that. Okay, so now you find this on your table, and we'll see how we'll move on from there. So this is basically what you will be doing. So I won't solve this one for you. You will know how to work out these probabilities. So this will be part of your task. Then yeah, so you work out these problems. So you also be practicing. So so for this one, it's the same thing. You are given the mean, the standard deviation, the random variable is less than 1.7. So that is probability of x less than 197. So you write it like that. So for this one, between, so meaning that x is between this, so you start with the small one, so that is 198.5 less than x less than 199.5. okay, so that is between. Same applies here. You just read what this, you convert, you do the same here, you do the same here. Yeah, so then we'll come and look at maybe question number 7. So I'll be waiting for this task. Have a good day and evening.